Okay, so Monday we talked about linear versus nonlinear, or we started the linear versus nonlinear section, but we only talked about linear. I'll get my ducks in a row here in a minute. So we talked about what it meant when it is linear. In other words, the x and y variables have a relationship that is constant and it makes a straight line when you graph it. X is what's called your independent variable, meaning that it's going to do what it wants to do and nothing can affect it. Y is your dependent variable. It means that you don't know what it is unless you follow the function that's affecting x. It's built off of the slope-intercept form. You probably remember slope-intercept form is y equals mx plus b. We are going to use y equals mx plus or minus b because, you know, b is your y-intercept, and sometimes your y-intercept is positive and sometimes it's negative. The growth rate, if it's linear, it means it's changing by the same amount with each independent variable. So every new independent variable that you get, the same function happens to it as happened to the one before it and will happen to the one after it. Slope-intercept form is the model used to build a linear equation. It works like a formula, and here it is. Y equals mx, which means m times x, plus or minus b. Each one of those four variables represents something. Y is your output or your dependent variable. You cannot find y unless you do all this other stuff to x, which is your input or your independent variable. M is slope, and we mentioned on Monday that as the only reason I know that I can think of that m is the variable is because s was already taken. And then b, plus or minus b, is your y-intercept. Y-intercept is where the line comes across the y-axis or intercepts it. It's also the starting point if you're graphing it by hand. All right? Slope is how the y-coordinate or dependent variable changes in relation to how the x-coordinate or independent variable changes. So it's your vertical change over your horizontal change. All right? For slope, you need a minimum of 2 points of data. So to find the slope or even to draw a line, you need 2 points of data. And they're called ordered pairs. You probably remember ordered pairs. And the first ordered pair are your x1 and y1 coordinates. Your second ordered pair is your x2 and y2 coordinates. And they're called that because that is how they fit in the slope formula. The slope formula is your change in y or your vertical change over your change in x or your horizontal change. That's why a lot of teachers call it rise over run, how it changes vertically over how it changes horizontally. And there's the formula, y2 minus y1 over x2 minus x1. Okay. And again, the y-intercept is where the line will cross the y-axis. It's the starting point of your graph, and it can be positive or negative. So if I were making you graph this out by hand and turn it in, like, you know, if we didn't use Moodle to check our stuff, then you would always mark the y-intercept first and then follow the slope to the second point. So here's some examples of how this works, okay? This is a function table. All right, it says this section is called using the function or the equation to find your y. Okay, so you'll start out with a linear equation or a linear function, and it's in that y equals mx plus b format. Y equals mx plus or minus b. In this case, it's a plus. So you'll have given x's, meaning that they'll already be there for you to use. You won't have to just pull them out of thin air. So in this one, I gave you 3 x's to check. So your function table has 4 columns. First, your inputs. What are your 3 inputs or 4 inputs or 2 inputs or however many that you have? And then I just realized I misspelled substitute on that first one there, but oh well, can't fix it now. You substitute them in to the equation. So if this is x, negative 2 is going to go in place of that x, right there, right? And when you substitute, it helps if you use parentheses so that you can see that it's something that was not originally there. So 2 times negative 2 plus 4, now it's just order of operations. Multiply, add, and then you get 0 for your y. So then, if you've got this x, this y, that makes your ordered pair. Negative 2, 0. Now, this and this are special ordered pairs because they have zeros in them. If they have a 0, they sit on an axis. It's just where the 0 is depends on what axis it sits on. For instance, if this says negative 2, 0, it has a 0 in the y place. That don't really look like a y at all. So this is then your x-intercept. But we don't really do anything with that because x-intercept isn't in the formula that we use. There are things that you can do involving x-intercept, but we're not going to mess with it. So this one has a 0 in place of the x. So now that's how we know that it is the y-intercept. If you look at the formula, we know that right here is where the plus or minus b is. And we said on the previous page that that's your intercept. So that matches this, positive 4, positive 4. So yeah, with the function tables, you just take your x's, plug them in with substitution, do your order of operations, and then get your y. On your lab, you're not going to have to put it together as an ordered pair. You're just going to have to find the y. All right? So graphing them is where this kind of comes in. That is not what I meant to hit. So, graphing using points or the equation. So, going back to that table that we just had, okay, we had 3 points off of that table. Negative 2, 0. I apologize, this didn't really come through that well. But we had negative 2, 0, 0, 4, and 1, 6. So you mark them on your coordinate plane. And then line it up, draw a line, and it's straight as an arrow, right? Okay, that's if you use the points. Now, something to make note of, okay? Using the points is the easier way, but it takes longer. Okay? It's easier, but it takes longer. All right? Whereas using the equation is pretty fast. All right? Look at your equation. Y equals 2x plus 4. Okay? So that means, where's my zoom? That we're going to use two pieces of this. We're going to use the y-intercept, and then we're going to use the slope. Okay? So first thing you do, you mark your y-intercept because that is your starting point, right? So you mark your starting point. We know that our starting point is at positive 4, so we mark positive 4. Now the slope says 2. The slope likes to be a fraction when you're graphing, and here's why. Because if you just did 2, you would move up 2 places, mark your point, and then you would have no line because it would be sitting on top of the y-axis, right? If it's a whole number, you have to stick a 1 underneath it so that you know that you're going up to right 1. That's what that means. Up to right 1. Up is positive movement. Down is negative movement. Right is positive, left is negative. So positive, positive, negative, negative. All right? So, like we said, you only need 2 points for a line. You only need 2 points to find slope. So we threw that in there, and then you're good to go. All right? So just, be aware of that because I think you might have some questions that say, what is the slope of this line? Just using the points or something to that effect. Okay, reading graphs. So here's one that's already been pre-built. So when you're reading graphs, the steps are pretty much the same. First thing, find the y-intercept. The y-intercept on this one is positive 4, so our b is 4. Next, find the slope by walking to the next point. You always find the vertical change first because it goes in the top of slope, and then you find the horizontal change second. So that's why we went down to, right to get to the second point. So if you go down to, right to, that's going to make negative 2 over 2. Now, slope does like to be a fraction, but it likes to be a simplified fraction. So that's going to make negative 1 over 1, and then if we're making an equation, you just use negative 1. All right, so build the equation. We found that the y-intercept was 4, slope's negative 1. Pop them in your y equals mx plus or minus b to get y equals negative 1x plus 4. Now, if I was just having you do this on paper, like out of the book, this would be fine with me. This doesn't bother me at all. But, you know, the bookmakers and all that, they say this isn't simplified. They don't like having that 1 there, so they like this. Y equals negative 1, or y equals negative x plus 4. It's implied that the 1 is there. Okay. We finished out with how to use the slope formula. Okay. So you substitute. I don't know why that looks different. Not going to worry about it. Not going to worry about it. All right. So slope formula. The best way to learn a formula is to write it down every time you use it. So every time you have to find the slope using 2 points, write the formula down. y2 minus y1 over x2 minus x1. Pop it in. Remember your rules for adding and subtracting negative numbers. And then like in this case, it came out to be negative 4 over 3 because you reduced the negative 8 over 6 and you're good. This one here on 5, it comes out to be 4 over 2, which will be 2 over 1 or just 2. So just remember, if you're graphing, you need it as a fraction. If you're writing an equation, you can use the whole number. But like in the case of negative 4 over 3, you're just going to use that as it is. All right. So that's the quick run through of everything that we covered on Monday. All right. And that was, I must have just like uploaded an actual picture of the page instead of scanning it. I don't know. But anyway. All right. So let's talk about nonlinear now. Okay. Oh, here. Where'd it go? Where is the mouse? Oh, there it is. It did this Monday, didn't it? Got stuck like this. Let's do this. Close that. And then let's close that. Okay. All right. So in the Moodle, I uploaded some pages from the Big Fat Math workbook, which is something that I have. That's not what I told you to, or that's not what I put as supplemental in the syllabus. The one that I put as supplemental in the syllabus was the Big Fat Math notebook, which I'll show you some pages from that too. But I was looking at it and I was like, I can't explain it any better than what they've got in here. All right. So if you look here, the first thing I uploaded yesterday is an example of a function table. Okay. So your equation is 5x plus 2, and it walks you through these 4 different inputs, how you substitute them in, get your output, get your ordered pair, and then walks you through how to graph them with the points. Pretty straightforward. And then here's some more information about slope, like with the different kinds of slopes. You do have some questions about what kind of slope it is. One thing that we didn't talk about on Monday is, let's do this. One thing we didn't talk about on Monday is the fact that, I don't know why I can't zoom this in, but anyway, a positive slope leans to the right, a negative slope leans to the left. We didn't talk about straight up and down or straight horizontal lines just because I'm trying to keep it minimum. But yeah, there is some more information about finding slope. All right, Nonlinear functions. All right, so we're going to start with, well, oh, it's over here. Drawbacks of having an extended desktop. Okay, so this one isn't in Moodle. This is just saved to my photos. I'll probably upload it as a folder later. But, all right, so nonlinear functions are not straight lines when they're graphed, and they are not in the form of y equals mx plus b. One example of a nonlinear function is a quadratic function. In a quadratic, the input variable is squared. All right? So the result is called a parabola, which is a U-shaped curve. So this example here is built off of, you know what? This thing is really aggravating me. There we go. All right. So the example they used, they created an input-output chart using the formula y equals x squared. That was it. It was just y equals x squared. Okay? So with y equals x squared, you've got your inputs. All right? I want you to notice something real quick. Okay? Let's see. Where is my marker? Yeah. All right? Okay. So, -3. Okay? So -3 goes into x squared. Of course, we know that this really means, -3 times -3, which is where the 9 comes from, and you get -3, 9. So -3 makes a 9. Let's skip down here to the bottom where +3 is. -3 squared is 9. +3 squared is also 9, right? And here's where the U shape comes in, because you've got two sets of ordered pairs that share a y value. All right? And there's a rule about functions that either the domain or the range can't repeat. It's been a while since I used it, but either way, I think it's actually the x's. So this is still a function, but it's not a linear function. Same thing with the 2's. So -2 squared makes 4. +2 squared makes 4. -1 squared, +1. +1 squared, also +1. So you've got different x's that go in order, -3, -2, -1, 0, 1, 2, 3. But your y's, 9, 4, 1, 0, 1, 4, 9. They're the same, except for the 0. So what does that do? Well, here's where that U shape comes in. So they take these points and they graph them. Okay? -3, 9 is right here. Okay? -2, 4 is right there. -1, 1, and then 0, 0, and then +1, 1, +2, 4, +3, 9. So it loops and comes back around. That's why it's a parabola. All right, so parabola is a U shape, and it goes with quadratic functions. Now, the only thing that changes this really, if you start doing like a putting a +1 or a -5 on it, that's going to shift your y-intercept. So like a +1 is going to move it up, and a minus would move it down. If it had something beside the x, I think that adjusts whether it is wider or narrower. We'll see. All right. So any questions about x squared, quadratic, parabola, stuff like that? Like I said, after class, I'll get these uploaded into Moodle for you. They're not in there right now. There is some stuff in there, but it's just a different page. Okay. So the next thing, oh, for Pete's sake. Why would anything work today? I mean, that would just be too easy, right? There we go. Okay. So here is another example. Actually, you know what? I'm just going to leave this over here and download it. That'll be the easier thing to do. There we go. Okay. So this is an input-output chart. All right. So notice how this one is flipped upside down. It's because, not because of the 2, but because of the -2. If your coefficient is negative, it flips it over. And it mentions that down here in this little call-out box. In the second example, y equals -2x squared plus 1. The coefficient in the front of x is -2. So if it's negative, it opens downward. All right, if it's positive, like this one was, it opens up. But if it's negative, it opens down. Okay? So the way the function worked was they used -2, -1, 0, 1, and 2. They popped them in, and they got those values. Of course, it's just like we did yesterday, except now you have an exponent. But you substitute it, do your order of operations, and you're good to go. So that made -2, 7, which is here, -1, 1, which is here, 0, 1 is there, 1, -1, sorry, and then 2, -7. Why was it 0, 1 instead of 0, 0 this time? Because there was a +1 right here. It actually had a y-intercept other than 0. So that shifted it up, but the negative flipped it over. So that's why that one's different. All right. So the main thing to take away from this, though, that you're going to see, because you only have like 5 questions about nonlinear stuff, is can you input it? Can you work it correctly using the exponent? I think there might be some where, you know, is this a quadratic, or is it like the next one, which is absolute value? Okay, so absolute value is different. Another example is absolute value, and absolute value is easy to spot because its graph makes a V. It does not curve. It is just it makes 2 linear rays that are joined by a vertex. So this example here, they did an input-output chart for y equals the absolute value of x. Just easy peasy, okay? Of course, we know what absolute value does. Absolute value tells us distance from 0, right? And because it's distance, that means that anything that goes into those absolute value bars will come out positive, and then you can do the other stuff that affects it later. So like this, it's just absolute value of x. So if x is -2, y is +2. -1, +1. 0, 0, 1, 1, 2, 2. So you take those 5 points, and then you graph them. This thing is zooming way too fast. All right, so stop. So -2, 2. Clear that. -2, 2 is here. -1, 1, 0, 0, 1, 1, 2, 2. So it doesn't curve, okay? It just makes 2 rays that are linear and joined by a vertex. That's why it makes a V. All right? And absolute value graphs, again, are easy to spot because they make a V for value. Now, of course, you know, if you ever take anything higher than this, it's not always going to be as easy as y equals absolute value of x. In some cases, it's going to be something, you know, more along the lines of this one. Y equals the negative absolute value of x plus 1. Of course, we know that if the negative is in front of the coefficient, it flips it over, right? And then if it has a +1, that shifts it vertically because it has a different y-intercept. So they ran the work. What you can see here is, again, it's just substitution in order of operations. Got their points, then they graphed it, right? So -2, -1 is right here. -1, 0 is there. 0, 1, 1, 0, and then 2, -1. Again, the negative in front of the absolute value bar flipped it over, all right? So if the negative is in front of the coefficient with nonlinears, it flips it vertically. No. Yes. Yeah, flips it vertically. Got confused there for a second. All right. Okay. So let's look at the other stuff that I've already got in Moodle. Okay. So, down here. All right. So, all right. So this actually came from the workbook. So the workbook doesn't really go into much detail, as much detail as far as like, this is quadratic, this is absolute value, and here's why. So again, the difference, quadratics are U-shaped. Absolute values are V-shaped. Quadratics are curved because they have the exponent. Exponential graphs, at some point, the change, you can't really see it because it's so drastic. It just looks like a straight line. It changes very quickly at first, but then you can see it kind of starts to taper. Whereas absolute value is just two rays that are just going off like this. So here's another example of quadratic. So it was 3x squared plus 1. So the 3 is going to, you see how it's a little bit narrower than this one is here? All right. If it was 1/3, see, I think 1/3 makes it, I don't want to speculate because I've not done it in so long. But anyway, so 3x squared plus 1. So 3 times negative 2 squared plus 1, you just do your order of operations. So you've got negative 2 squared, that makes a 4. 3 times 4 is 12. 12 plus 1 is 13, blah, blah, blah. Work it on through, and then you've got your points, and it's quadratic, so it's going to curve. All right? And then, come on. We've got more with absolute value here. Okay? So with absolute value, again, you've got the fact that it makes a V shape. Absolute value, everything that goes into the absolute value comes out positive. Your y-intercept is -2, which is there. Whoa. All right. And then your negative outside your absolute value means that it's going to flip vertically. So that's why it looks like that. All right. Okay. Let's go ahead and take our break now, and then when we come back, we will look over your lab, because I forgot to make a handout or a preview for it, and it'll take me about 10 minutes to do that. So let's go ahead and take our break, and then we'll come back at 9. We'll just say 9. We'll come back at 9. Let me pause the video real quick. So yeah, on the, where's it at? On the lab, again, remember it's going to shuffle them when you open it up, so they may not be this order. You've got a lot of plug in X, find the Y, and then when you get to 13 and 14, where it's asking you about the different slopes, that is found right here on this block that says slope in this page right here. Talks about positive, negative, undefined, and 0 slope. We didn't really do anything with undefined and 0 because, like I said, I was trying to keep it minimum. There's a lot you can do with slope, though. Okay, so 14 is along the same vein. 15 says, find the slope of this line, either use the slope formula, walk it like we did in the notes in the video, or use the slope triangle method from the Big Fat Math notebook. So the slope triangle is basically what we did when we walked it on Monday. So the slope triangle is here, and it says, draw a right triangle to get from A to B, find the rise and run. So you see you got these 2 points here. You're going to go down 4 until you get level. You're going to go down 4 until you get level with this point. Then you're going to go over 5 until you get to it. So that makes a slope of negative 4/5. Always do your vertical first, then do your horizontal. Okay? So that is the slope triangle. You're making a triangle by finding the left and bottom, or sometimes the right and bottom, whichever way it's leaning. But there's that. Okay? That's walking the slope like we talked about. Okay? 16, find the slope of that line. Use the slope formula. Again, you can use the formula. You can walk it, whichever one you want to do. 17, you've got 2 points. Use the slope formula to find the slope of that line. Okay, y2 minus y1 over x2 minus x1. Same thing for 18. All right. 19, I had to handwrite the instructions. Look, just be glad it's in there. The way that things have been working this week, okay, just be glad that you have a question to answer. There are students in other places that do not have access to this kind of educational material. All right? So there's your equation. All you have to do is identify which part is the slope, which part is the y-intercept. That's all you have to do. 18 and 19 are the same. And yes, I just slid the paper down to the next question and took another picture. Work smart, not hard. All right. So now the last ones on your student copy, 21 through 25, deal with quadratics and absolute values. Okay. I couldn't remember if I'd put any of the graphs on here or not, but looks like I did not. I might throw one or two of those on the final for you, but for now, I just want you having practice working the function with your input to get your output. Okay, so y equals negative 3x squared minus 1 for these, and then positive 2x for those. Okay. This is due, when is this due? Whoa. All right, this is due April 26th. Okay, there is a work entry and there is an answer entry. All right, as you've seen from the function tables, there is work to do. It's not a lot, no, but there is work to do for these. Okay. Now, going back to the student copy, the only ones that do not need work are 13, 14, 19, and 20. All right? 13, 14, 19, and 20. Well, you can get away with not having any work on 15 and 16 too if you like walk it out, like if you walk the slope. Okay? So, all right. I think that's everything, but again, I don't know for sure. Probably not, knowing my track record. I'm sure there's probably something I forgot that'll be an announcement later that half of you won't get because you don't have your email logged into Microsoft Outlook on your phone. Well. All right. Any other questions? Remember that Monday, the 24th, is our last in-person class meeting. It's going to be a cram session of everything that we've covered to kind of get you ready for the final. The final opens on the 26th. All right. Yep. There's that.